Right, sorry I didn't make that clear at the beginning, that you are doing both part A and B of this question in those 8 minutes. So, just a thought actually when you're doing these, if you can't produce an answer in the time for these questions, and on a question like this one, this is actually a standard method, you should be trying to do it in half the time if you're an A grade, aiming for an A grade or an A star. So this one you should be able to knock off in 4 minutes. If you can't, then what I suggest you do is you actually put this video into your playlist, save it into watch later, and then you've actually got an automatic review program of questions you found difficult. So any videos you watch on YouTube where you can't do the question in the time allotted, then put those into the watch later and you've got an automatic review program which will ensure that you can do everything. Anyway, back into the question. We're going to differentiate. Now this has been written as x in terms of y, and you want to find dx by dy. So we've got a product rule. We've got two things. We've got this times by this function. So you've got y plus 5 times natural log of 2y minus 7. So we're going to use the product rule. So we're going to do the derivative of this times this plus derivative of this times by this. So dx by dy will equal the derivative of that in respect to y is going to just be 1. Okay, y goes to 1, the 5 goes to 0. So we're just left with natural log, and we times that by the natural 1 times the natural log of 2y minus 7. Add on to that the derivative of this using our product rule. So differentiation natural log, you're just going to get the derivative of 2y minus 7, which is 2, over the 2y minus 7. And then we need to times that by y plus 5. So let's just put it there. If you're timesing a fraction by a value, you times the top by that value. So that gives us our derivative of dx by dy in terms of y. Nothing more to do. We want to find the gradient of the curve where it crosses the y-axis. So it crosses, so I'm doing part B here because that will save me messing around with the screen. So it crosses the y at x equals 0. So therefore we've got 0 equals, okay, if x equals 0, we've got natural log of 2y minus 7 plus 2y plus 5 over 2y minus 7. Now, if we multiply throughout by 2y minus 7, okay, we're going to get 0 is equal to natural log of 2y minus 7 times by, I should have really put it at the front, 2y minus 7 equals 2 open brackets y plus 5. So I'm just doing a little thinking here because it wasn't what I did in my previous attempt to this question. For some reason, so I don't want an equals there, apologies. I want to do a plus there. So for some reason I've left this bit out. And I don't know why I've left this bit out in my original question. Okay, no, let's just carry on. Find the gradient of the curve where it crosses. Oh, that's what. Sorry, I know what I've done. I've put it into the wrong equation. I'm being stupid. Sorry, my mistake. I put this into the wrong equation. My class just helped me out. I was looking back at my old answer, and that's the sort of mistake you can make, and this is why you need 8 minutes to do this question when you make mistakes. So we know that x equals 0, so we're going to put that into there, and we get 0 is equal to y plus 5 times by the natural log of 2y minus 7. So either y plus 5 equals 0, or the natural log of 2y minus 7 must equal 0. And this implies that y equals minus 5. Now y equals minus 5, okay, is not going to work in this. Because if we put this back into our function, when you do 2 times minus 5, you get minus 10. Minus 7 is minus 17. You can't find natural log. So this doesn't exist in our function. So it's not going to be a point where it's going to cross the y-axis. So therefore, it's going to be here. Now, if this equals 0, then 2y minus 7 will equal 1. Because natural log of 1 equals 0. So 2y will equal 8, so y will equal 4. So therefore, now this is when I put it back into my gradient function. Sorry about that mistake earlier. This is the problem with doing these things live. So, just give us a bit more space to work with. Dx by dy is equal to the natural log of, put 4 into this, 2 times 4 is 8, minus 7 is 1, which we know is going to be 0, plus put the 4 into here, and we get 2 times 4 plus 5 over 2 times 4 minus 7, so that's going to be 1, that's going to be 9, 2 times 9 is 18, divided by 1, plus 0 will give us 18. But we want to find the gradient of the curve, and we've got dx by dy, and the gradient of the curve is given by dy by dx. So the gradient of the curve, when it crosses the axes, will be 1 over 18. Okay, apologies for that little mistake. Shows how you can get carried away by this is actually a very common mistake that students do make, and I've just made this myself, is to actually substitute into your wrong equation when you just made a statement. So crosses y x equals 0, so put x equals 0 into here, not here. Right, moving on to our next question. Yes, any questions on that? Oh yeah, quick question on why you can't use y equals minus 5. The reason why I can't use y equals minus 5 is when you go back to the original equation, and what you must always do is check, actually I didn't check for 4, I should probably check for 4 as well, and I will do in a second. Okay, if you put y as minus 5 back into here, it's the natural log part which will cause problems. Because you've got 2 times minus 5 is minus 10, minus 7 is minus 17. And basically, if you draw a graph of natural log of x, you can see there's no values for natural log of any negative numbers. So anytime you have natural log of something negative, you can't work it out. So this value will not exist in our graph because you can't work out the natural log of minus 17. Put 4 in, though. We get 2 times 4 is 8, minus 7 will give you 1. So actually that will give you x is 0, which is good because that's what we wanted to show. Okay, so that's not a problem there. Right, so next question. We have got 9 minutes to have a go at this one. This is a 9 marker, 9 minutes. See if you can pull this one out in the time. Ignore the time, I just realised it wasn't visible. I'm just going to change it to about 5 minutes to go. Right, time's up. So let's have a look at this question. We've got to find the exact values of x coordinates for stationary points of the curve. Now this actually, x cubed plus y cubed equals 3xy plus 35. This actually is a standard question, so it's another one where you should be trying to knock off in a lot less time than the marks. This is a 9-mark question, hence why I gave 9 minutes, but you should be trying to get it done in 5, really. So let's differentiate implicitly with respect to x. So we can differentiate everything with respect to x. We get 3x squared. When you come to the y bits, just treat it as if it was an x and then just times by dy by dx. Okay. Now we've got a product here. We've got a 3x and a y. Or you could do it as a 3y and an x. Doesn't really matter which way you do it. Differentiate the 3x, I get 3 times by the y plus differentiate the y and times by the 3x. So I get 3x dy by dx. So y differentiated goes to 1 times by dy by dx gives me dy by dx. Plus the 35, well, that differentiates to 0. So I now group my terms. Let's put all my dy by dx terms on this side. And then put all my other terms on this side. Actually, while we're here, we can just cancel out the 3's because there's a factor of 3 everywhere. So we can just get rid of that. Take out the factor of dy by dx, you get y squared minus 3 equals minus x, sorry, apologies. I'm looking at the wrong number. Thank you, class, for correcting me there. And we get y minus, I was about to write another 3 there as well. Got 3 in the brain on this question. Dy by dx comes out to be y minus x squared over y squared minus x. And you think, a lot of people, when they're not confident with this topic, thinking, what do I do now? Well, I know that stationary points occur when dy by dx equals 0, so this will equal 0. And a fraction will equal 0 when the top of the fraction equals 0. So this implies that 0 is equal to y minus x squared, so y equals x squared. No, it's not it. I just got asked if that was it in the class. No, because we have not found the values of the x-coordinates. So we know that dy by dx equals 0 wherever y equals x squared, and we know that our equation's that. So we substitute this into our equation to find the points where it happens. So I'm going to replace all the y's with x squared. So I get x cubed plus x squared cubed equals 3x times x squared plus 35. So what I've done is taken the y value, it's equal to x squared, so replace that with x squared, replace that with x squared. And now I've got a polynomial degree 6 to solve. Let's just create a bit more space because it can take a bit more space to solve this. So now I get x to 6. I've got x cubed. I've got 3x cubed. Take that away from x cubed. That gives me minus 2x cubed, and I bring it onto this side. So I've got x cubed minus 3x cubed. Take away the 35 equals 0. Now what you should realise here, those experienced A-level campaigners out there, is you have a hidden quadratic, because this is just x cubed squared. So let's just factorise that out as a quadratic, where we've got x cubes. And we've got minus 35, which is 7 times 5, and we know that they differ by 2, so we can put a minus 7 there, and a plus 5 here. So either x cubed equals 7, or x cubed will equal minus 5. So x will equal the cube root of 7, or the cube root of minus 5, which can be worked out. Odd powers can work out negative. It's when you've got even powers you would not be able to do that. So we have two answers to this. It only asks for the x values. Okay, the exact values of the x coordinates we don't need to do any more. We could change that to put the minus out the front. It doesn't really matter where it goes, but that is that question. Any questions in my class? Once shown how to do it, I think it is quite straightforward. It all happens to know. If you just remember these little key points about the top of the fraction, then thinking, okay, I can put that back in to find my x values where it happens. Right, the next question is a biggie. Differential equations. 12 minutes, 12 marker coming up. Let's go. Right, if you struggled with this question and you've actually skipped the 12 minutes straight to the explanation how to do the question, don't watch this explanation right now. Pause it and go back and watch my video on how to do first order differential equations. So you have no clue how to do a first order differential equation, or you got completely stuck on this and couldn't see how to go to this. I would recommend doing my first order differential equations video first. It's about 40 odd minutes long. When you've done that, then save this one for a proper tricky exam question where you've got to use more techniques to try and solve a problem. Listening to me explanation now without having done that lesson, you'll actually lose out on a learning experience. But putting that to one side, let's get some more space because we're going to need lots of space to do this question. So I'm just going to grab myself a whole wad of space. Let's keep going, let's keep going. I'm going to take lots of space to do this question. So the first thing we've got here is we've got given this differential equation. I've read through the whole question, that's what I got, and I'm going to turn that into that. So first thing I'm going to start off with is I always write out the question that I'm going to deal with. And then the examiner can see if I've miscopied the question. And I don't like this as it stands. Okay, I know that I'm going to have to times or divide at the beginning to get this on this side. And I've got an n here and it's separated from this. I want to make this into a nice single fraction. I'm going to leave the 0.1 outside. And actually what I'm going to do is make this into and the n to start off with. I'm going to write this as one fraction. So this is the same as 50 minus n over 50. If you can't see that, 1 is 50 over 50. So 50 over 50 minus n over 50 is 50 minus n over 50. And then I can multiply out through by my n. Over 50. And now I'm getting to the stage where I'm going to divide this by this. Now, because this is a single fraction, if I divide by it, I end up timesing by the reciprocal. So I'm going to times by 1 over this, which is going to be 50 over n, 50 minus n, dn by dt. So all I've done is I've divided by this, which means timesing by this. I've left the 0.1 over here, because I like to leave a number over here. It could be 1, it could be 0. I could have taken the 0.1 over here and left a 1 here, but I didn't. And then remember, if you've watched my video on first order differential equations, the next thing it says to do is to split this fraction up. Now this is a bit noddy and it's not how you should do these things, but it actually makes it the easy way to remember how to do them. So done that, but I realise I'm going to have to integrate this, and this is not very nice. So I'm going to then put my integral signs in, because that's what you're going to do. But this is not very nice to integrate, and I realise I've got 50 over n and 50 minus n here, so I'm going to do a bit of partial fractions to turn this into something easier to integrate. So I'm going to write 50 over n, 50 minus n, as a over n plus b over 50 minus n. Therefore, now to get my top bit of this, when I combine these two, I do a times 50 minus n, because I times top by my 50 minus n. I do b times n, because I'm going to get b, and I'm going to get n over n. So that gives me the same denominator. So therefore, I'm going to get a times 50 minus n here, plus b times n. If we let n equal 0, this will become 0. So this will become 50, so a will equal 1. And if we let n equal 50, this will become 0. And we get 50b equals 50, so b will equal 1. So now I can rewrite this as my partial fractions. So I've now got 1 over n plus 1 over 50 minus n dn. I may as well integrate this while I'm here. 0.1x plus c, which is nice to see the 0.1, because we're going to get a 0.1, and it's not an x because we're in terms of t, so let's just change that to a t. The joys of using OneNote to do maths. Back in the days of paper, that would be a crossing out. Now, integrate this, we get natural log of n. Integrate this, we get minus the natural log of 50 minus n. This minus, when we differentiate this, will come out. we don't need 2 plus c's, we only need 1. Because if we had a plus c on this side and we have a plus c, so we call this plus k and plus c, we could take them away from each other and get another constant. So what's the point in having 2 constants? Now, what am I going to do here? I'm going to write this. When you've got these logarithms, you want to try and get a single logarithm like we got a single fraction here. Okay? So to subtract these, that's equal to, using my logarithm laws, I know that this is true. Once I've got my single logarithm, I can now use the inverse of this, which is e. Raise both sides to the power of e. If I raise this side to the power of e, I get this, because e to the natural log of that will cancel to just leave you that. But I get e to the 0.1t plus c. Now notice they've got a times 50 going on here. Now, my instinct, whenever I do one of these questions, is to take this plus c and turn it into an a times e. Well, how do I do that? Well, e to the 0.1t plus c is equal to e to the 0.1t times by e to the c. Remember, if you're timesing 2 powers, these two things, you add the powers to get that. Now, e to the c is just another constant. We could call that a. So we've got e to the 0.1t times a, which equals a e to the 0.1t. So I'm just going to replace all of this with a e to the 0.1t, where a is a constant. Okay, that's my little bit of side working for that. Now, what I need to do next, I need to make n the subject. This is quite a marathon, this one. Let's keep going. So we're going to make n the subject. So let's times throughout by 50 minus n. So I get a e to 0.1t times by 50 minus n. So n will equal 50 lots of a e to the 0.1t. We're starting to see some familiar things come through. Minus n a e to the 0.1t. Get all the n's on the same side, so I've got n plus n a e to the 0.1t equals 50 a e to the 0.1t. Let's factorise this out and get n out as a factor. 1 plus a e to the 0.1t equals 50 a e to the 0.1t. We're going to get there soon. Divide throughout by this, where you get n equals 50 a e to the 0.1t over 1 minus a e to the 0.1t, which feels like we got to the answer. But we haven't. Because we got 50a over e to the minus 0.1t plus a. Now, so how do I get that? Well, there's a 1 there, and there's an e to the minus 0.1t there, and there's an a, and there's an a here. Pardon? Why is it my a? Oh, so I've just made a mistake, and it's well spotted by one of my students. I forgot to put a little plus there. Okay, so what I will notice is, I'm just going to grab this and put them next to each other. So let me just do a bit of copy and paste. Just grab this little thing and put it next to where I got to. So I've done all that work, and I think, yes, I've got to an answer, but it's not quite the same. Now what I will notice is, if I times everything by e to the minus 0.1t, I get the right answer. Times this by e to the minus 0.1t, I'm just left with 50a, because this is, if you do e to the 0.1t times by e to the minus 0.1t, you add the indices, you get 0, and e to the 0 is 1. So therefore, times this by e to the minus 0.1t, I just get e to the minus 0.t, and then again I'm going to get e to the 0, which is 1, so it just gives me a plus a there. So actually, this is one of those moments, if you can't see how to get from here to here, just write it out and hope for the best. And you may pull it off that the examiner may believe that you just knew how to get from there to there and you've got your answer. Because actually it is just a one-step problem from there to there. So we've now got our answer. Any questions in my class at this stage? No, it's quite a marathon, that one, in terms of algebraic manipulation. if you really know your stuff, if you to do this question, you've got to know that generally writing things as single fractions makes your life easier. You've got to know how to do partial fractions, and then you've got to know all the bits about differential equations and the e's and all the powers and how these ones tend to come out as a times e to the t. Now, using this model, determine the maximum number of birds that John would expect to observe at any given moment in the long term. So as t, as t tends to infinity, this is going to tend to 0. E to the minus 0.1 t will tend to 0. So if this tends to 0, this is going to tend to, therefore, n is going to tend to 50a over a, which is just equal to 50. So the maximum number of birds is expected to observe any given moment in the long term is going to be 50. Write down one possible refinement of this model. So one of the problems is this model at the moment we have t as an integer. T is continuous. So therefore we could make t an integer. Okay, we might want to say that t is an integer. We also could consider all species of birds in one go. So we might separate out species. Is another thing we could do for that. Another thing I think we also, it'd be quite nice to have an initial value to find a. Okay, it'd be quite nice to get an initial point at the beginning to find a. Right, one way when it's not inappropriate, well, the fact that his is continuous, he's got t is continuous, and days aren't continuous. Okay, each day is just one discrete unit in itself. And again, you might say that it treats all species the same. Having the same patterns. So that may not be true too. So there's two possible ways where it's not appropriate, which actually tie in nicely with the refinements. If you're going to make a refinement, then it's quite possible that refinement points to how your model is not appropriate. Okay, so if you found this really tricky, I suggest you go back and do my lesson on differential equations. Anyway, that's the end of today's stream. I hope you enjoyed it.